Looking at P.9, Part 2, solving a compound inequality. Compound inequality, compound like a compound sentence, you're putting two sentences together. A compound inequality is putting two inequalities together. So we're going to solve and graph the solution set on a number line of 1 is less than or equal to 2x plus 3 is less than 11. So it says that our goal is to isolate x in the middle. So if we solve to get x all by itself, we have a 2 in front of the x and a plus 3. So we're going to get rid of that plus 3 first by subtracting 3, but not just from what's happening on the inside, but we have to do it also to both of the outsides. So 1 take away 3 leaves us with a negative 2 is less than or equal to a 2x, which is less than 11 minus 3 leaves us with 8. If we divide by 2, we end up with a negative 1 is less than or equal to x, which is less than 4. Now that would be our set builder notation. So it says we're going to put it in interval notation, and we're going to put it in set builder notation, and then we're also going to graph it. So that set builder notation would tell us x such that negative 1 is less than or equal to x, which is less than 4. And maybe after the practice that we had with our interval notation, you're already able to go ahead and identify what that's going to look like. If we are or equal to a negative 1, that is where we have our bracket. And a negative 1, we put a comma. We're going up to 4, but not including it, so we need a parenthesis. So the number line graph, we're going to go to our negative 1, and we are going to open up our bracket. And then at positive 4, we're going to have a parenthesis. And this says that we are going to be somewhere in between. Anytime you have a compound inequality where x falls between those endpoints, you're obviously going to be between those two endpoints. So we have our bracket when it's or equal to, and we have our regular parenthesis when it's up to but not including. The other type of inequality we're going to look at solving is our absolute value inequality. Very similar to our absolute value equation where we had two bars, we had two problems, but now we have a little bit more to look at in terms of when we split it into those two problems. It says if u is an algebraic expression and c is a positive number, if you remember when we did those absolute value, we said that the distance from 0 has to be positive. So we're still looking at c being a positive number. Number 1 says the solution of the absolute value of u is less than c are the numbers that satisfy. Negative c, or the opposite of c, is less than u, which is less than c. Now, if you think about that, we have a less than. And if we have a distance from 0, here's my 0. If I go c units away and I go negative c units away, if I am less than c units away, my distance from 0 is less than c units away, which means that I'm also less than, so to speak. It's in between those two endpoints for a less than. So I'm smaller than that distance from c to 0, which is why u is going to end up in the middle. And then the next one says the solutions of the absolute value of c are greater than, the absolute value of u are greater than c. Then the numbers are u is less than negative c or u is greater than c. Well, what does that mean in terms of the number line? Again, if our distance from 0 is c units away, and we're negative c units away, so to speak, if the absolute value of u is greater than c, that means that we are greater than c. We're going away from 0, which means that we're also going away from 0. So it's going to go to the extremes, to the infinities, positive infinity and negative infinity. Now, if you go back to Algebra 1 kind of concept, when you're in between, for instance, this first one here, when you're in between those two endpoints, we called that compound inequality an and. And if you're going either or, this would have been an or type of problem. So it says that these rules are valid if your less than sign is replaced by less than or equal to, and your greater than is replaced by the greater than or equal to. Any of those signs are interchangeable. So let's take a look. It says solve and graph the solution set on a number line. We have 18 is less than absolute value of 6 minus 3x. So it says that we begin by expressing the inequality with absolute value equation the absolute value expression on the left-hand side. And then it says we're going to rewrite the inequality without absolute value bars. So just like what we did with our equations, we have 2 bars, we're going to have 2 problems. And I don't memorize whether it's an in-between as an and or an outside as an or. I just write them as 2 problems and solve them from there. So in this case, 2 bars means that we're going to have 2 problems. I'm going to write over on this side though. So we're going to have our 6 minus 3x is greater than 18. Just like our equation, exactly how it's written, we would write it out, right? We don't have anything from the outside of the absolute value bars to get rid of to begin with. And then when I go to my opposite value, I'm going to have 6 minus 3x. And if I'm changing from a positive 18 to a negative 18, I'm really taking the opposite sign. And if I'm taking the opposite sign of that number, I'm also going to take the opposite inequality sign. So the easiest way to do any of these absolute value inequalities is when you have your 2 bars, right? Everything else was gone. 2 bars makes 2 problems. One is the positive and one as the negative, but think of it as the opposite. So when you go opposite, you need opposite inequality sign and the opposite number. So then we're just going to go about solving them. So we had our 6 minus 3x is greater than 18. We have a 6 minus 3x is less than negative 18. And you guys all know how to solve equations. All right, subtract 6. Negative 3x is greater than a 12. Dividing by negative 3. X is greater than a negative 4. Oops. Mistake on Mrs. Barishman's part. What happens when we divide by a negative? I was going too fast. You have to flip your inequality sign, right? 12 divided by a negative 3 would be a negative 4. If we go to our other one and start solving that down, subtracting our 6, negative 3x is less than a negative, what do we got, 24. Dividing by a negative 3, I'm not going to make an oops again. I divide by a negative, I also have to flip that inequality sign, and so we end up with our positive 8. And so it wants to know our solution set and then to be able to graph it. So our solution set, set builder notation, interval notation, we can kind of show both. If we have x is less than negative 4 and x is greater than 8, sometimes it's easiest to just go ahead and graph it first and then go back and figure out what in the world we're trying to write out for our solution set. So if x is less than negative 4, it's a less than, and I'm going a less than negative 4. That means I'm going to have a parenthesis going this way. And then if I have x is greater than 8, if x is greater than 8, whoops, I don't have an 8 on here, so I'm going to throw a little 8 on here. And I'm going to have an open parenthesis again this way, and we're going towards the infinity. That means that I can say that I would have x such that x is less than negative 4, or x is greater than a positive 8. And set builder notation would say that we're going from negative infinity up to negative 4, not including it. And I have from an 8 going to a positive infinity. And in all of those cases, I would have those parentheses because nothing is or equal to.